let's keep going with transforming trigonometric functions. Now, there is a link, it's in your Google Classroom, but it's right here too, that I'd like you to go to and take a look at your sine graph. And I've put in a slider for the value D, so you see where that's located. And then try to figure out how does that transform our function. So I'm going to ask you to pause the video right here. Go to this Desmos calculator. You can use the link here or use the link in your Google Classroom. And take a look and just use the slider to look how that D value affects your graph. Of course, even though we're just using y equals sine x as our function, the exact same transformation would occur if we were using cos. Okay, so just realize this works for both sine and cos. Okay, so this was the function that was in Google Classroom or in the Desmos activity, y equals sine x minus d, and that's in brackets. So d moves it left or right. So that's what you should have figured out, is that it transforms this left or right. We don't call it left or right. We call it a phase shift. So this is really important as part of our terminology for this unit. So if it goes left or right, it's called a phase shift. And that we have to remember that when we're taking a value outside of our brackets, of course, it changes signs, because what we're actually doing is we're taking this, whatever's in the brackets, and putting it equal to 0, which means x equals d. So if it's negative in the brackets, when it comes out, it'll be positive. If it's positive in the brackets, when it comes out, it'll be negative. Okay? Just to remember that. All right, so let's look at our sine function, and we're going to graph actually a bunch of functions, but before we get started, we need our base graph. So our base graph of sine starts at 0, 0, and then at 90 degrees, it goes up to 1. At 180 degrees, it's back to 0. At 270 degrees, it's at -1. And 360 degrees, it's back to 0. So that's our graph, of course, that looks like this. And that we're going to use our base graph in order to help us graph. So now that we're starting to look at multiple transformations, our amplitude, our axis of symmetry, now we're throwing in a phase shift. We're going to start using our table in order to help us figure out what the graph looks like. And knowing your base graph will certainly help you. So let me actually go to the next slide. So I have a grid here. Here's my grid. And the first thing I want to graph is just y equals sine x. So remember, this had our base graph at 0, 0, 90 and 1, 180 and 0, 270 and -1, and 360 and 0. So we'll do this graph in red. I have 360 along my x-axis. I've gone up by 30s. And then I went in between -3 and a +3 on my y-axis, just in order to accommodate all the graphs that we're going to do. All right, so my sine graph starts at 0. And then at 90, it's at 1. And then 180, it's at 0. And then at 270, it's at -1. And then 360, it's back to 0. So in red here, there's our first graph, our sine graph. Now, to show that it continues on, of course, in either direction, we're going to put some arrows at the end to show that it continues, because this is periodic. Okay, so how about if we wanted to graph y equals 2 sine x? Now, I know you can do this without a table of values, but I want to show you how you do it with a table of values, because as we get to more and more transformations, it can be organized in a table very nicely. And I'm actually going to be asking you to create tables to go along with your graphs. And so it's important for us to take a look at what's happening. So this too is a change in our amplitude. So let me go back to my original sine graph. So 0, 0, 90 and 1, 180 and 0, 270 and -1, and 360 and 0. So there's our original. That's our base graph, our base points. Now, when we changed our amplitude, we changed it to a 2, means that we ended up multiplying our function by 2. So we know from transformations from previous functions that if we multiply our function by 2, that's where I'm going to multiply my y values all by 2. So 0 times 2 is 0. 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2. And 0 times 2 is 0. And so my new points, of course, because we use our outermost columns, ends up being these values. And now if I go back to my graph, I'm going to graph 0, 0. So let me go here. So 0, 0. And then at 90, I'm going to be up at 2. And then at 180, I'm back at 0. 270, I'm at -2. And 360, I'm at 0. So notice, of course, we have this. We've changed our amplitude. So we've changed the height of the wave. Okay. So if your amplitude is going to change, that's a multiplication to your y values because because that 2 is being multiplied to the whole function. Let's keep going here. Let's try another one here. All right, so let's do this one in blue. Y equals sine x plus 1. So again, you're going to start at 0, 90, 180, 270, 360. We're going to start with our base graph. 0, 1, 0, -1, and 0. Now, this plus 1 is being added on to the end. So when we add on to the end of our function, okay, that is our axis history. We know that, but it's our vertical translations from previous functions, transformations of functions. So this is where we're going to add 1 to all our y values. So 0 becomes 1. 1 plus 1 is 2. 0 plus 1 is 1. -1 plus 1 is 0. And 0 plus 1 is 1. All right, so in blue now, if I go back up, so what's changed actually is this is our new axis. It's our new sinusoidal axis, sorry. Okay, and it's going to be at plus 1. So I could almost just put like a broken line just across. That just lets me know that's where kind of that halfway mark is. All right, so my first point starts now at 0, 1, and then 90, 2, 180, 1, 270, 0, and 360, 1. All right, so 0, 1, and then it went to 90, 2, and then it went to 180, 1, and then 270, 0, and then 360, 1. So let's take a look. And as you can see, if you compare it to the red graph, you can see that it is the sine graph and it has been moved up 1. So that's looking really good. Okay, one more. So this is where I want to take a look at the phase shift. And let's do this one in purple. So again, I start with my base graph, 0, 0, 91, 180, 0, 270, -1, 360, and 0. And notice we have this -90 inside the bracket. So if we take it outside the brackets, it becomes a +90. What it's telling you to do is we want to move this to the right by 90 degrees. Okay, so this is going to go right by 90 degrees. And since it's going to go right by 90 degrees, what we're going to do is go over here to our X column, and we're going to add 90 degrees to all of those values. So 0 plus 90 is 90, 90 plus 90 is 180, 180 plus 90 is 270, 270 plus 90 is 360, 360 plus 90 is 450. Okay, so we're going to take our sine graph, we're going to move it 90 degrees to the right. That gives me these new coordinate points of 90, 0, 180, 1, 270, 0, 360, -1, and then 450, 0. All right, so let's plot these points on our graph. So the first one is at 90, 0. So that's right here, 90, 0. And then it goes 180, 1, which is right here. 270, 0, which is right here. And 360, -1. And then 450, which we don't have. But we can extend it over, which would go back up to 0. So it's about here. So we have this graph. Now notice, of course, we can fill it in over on the left-hand side. This would be then at 0. This would be -1 if we kept going. There we go. Okay, so if your amplitude changes, it's a multiplication to your y values. If your sinusoidal axis changes, then it's an adding or subtracting to your y values. And then if you have a phase shift, like in this last one, remember it is the opposite of when you take it out of the brackets, and it's an addition or a subtraction to your x values, which makes sense because this is in degrees in your brackets, and it's in our x values were also in degrees, so we can add degrees with degrees. Okay, so what if we start kind of putting this all together? Instead of having one transformation, let's have multiple transformations. So let's take a look at this function. Y equals -3 cos x minus 60 plus 2. So this is definitely a big graph in terms of its transformations. Before we actually go ahead and do the graph, I want to talk just briefly about what these transformations mean. So it's important for us to also understand what's happening with the transformations. So for example, this negative out front, the negative means that it's a reflection in the x-axis. That 3 means I now have an amplitude of 3. The 60 degrees, so it's a -60 in the brackets, but when I take it out, it becomes a +60. This is a phase shift. 60 degrees to the right. And then that +2 means that it's been moved up 2, but now our sinusoidal axis is at 2. Okay, so we're going to start with our base graph. Now this is cosine, so I got it right. Let me highlight this here. We're now talking about cosine. So we're going to put those cosine values in. So at 0, it's at 1. At 90, it was at 0. At 180, -1. 270 is at 0. And 360 is at 1. So here's our base graph for cos. And now we remember, just like before with transformations, we always apply them in the order in which they are given. Otherwise, then we won't get the proper graph. So let's start with that -3. So the -3 means I'm going to multiply all my y values by -3. 1 times -3 is -3. 0 times -3 is 0. -1 times -3 is a +3. 0 times -3 is 0. And then 1 times -3 is -3. So that we have our reflection. So now instead of starting up high and going low and then going high, it's now the opposite of that. It starts low and goes high and then goes low, which is fine. It's just a reflection. All right, next comes this -60. So when I bring it outside the brackets, it's going to become a +60 degrees. So I'm going to add 60 degrees to each one of these. So 0 plus 60 is 60. 90 plus 60 is 150. 180 plus 60 is 240. 270 plus 60 is 330. And 360 plus 60 is 420. All right, so we're almost done. Last is that +2 at the end. So +2. Of course, we're adding it to the whole function. It's a change in our sinusoidal axes. And let's go +2. And -3 plus 2 is -1. 0 plus 2 is 2. 3 plus 2 is 5. 0 plus 2 is 2. And -3 plus 2 is -1. Okay, so when we graph this, what the points that we're going to use are 60, -1. 150, +2, 240, 5, 330, 2, and 420, -1. Okay, so there's all our points that we're going to use to help us. So let me just copy these. Copy. And so we'll bring them over to, I have a graph. Whew. Okay, so the graph's a little big. Let me just kind of shrink this up a little bit so that we can see it here. All right. And paste. So here's my points. I'm just going to put them off to the side here. All right, so let's take a look at what this graph should look like. So it should be something that's reflected, should have a change in our wavelength. It should have a phase shift, so it's been moved to the right, should be up 2, so all those things. Okay, so remember this is going by 30s, 30, 60, 90, 120, 150, and so on. Okay, so 60 and -1, 150 and +2, 240 and +5, 330 and +2, and 420 and -1. So we have, and I have lots of room here. I could actually keep going because it is symmetric, right? Or it is a periodic function. So if I keep going here, the next one would be at 510, and it would be up to 2. So 510 would be up to 2. And then 600 would be at 5. 600 is here, and it would be up to 5, which is up there. And I'm adding 90 degrees each time. 590, and then my next number would be a +2 again. So 690. Right? So it continues on in either direction forever because it is periodic. Okay, so if you have a function that has multiple transformations, use your table to help organize those transformations so you end up with your points that you need in order to graph. All right. Practice some questions out of the book. And of course, if you have any questions, reach out to me and I will gladly give you a hand.